Welcome to Faith and Science. I'm Dr. John Ashton. A few days ago, I met with former classmates to celebrate the 60th anniversary of opening the high school I went to, and that was in 1959, and I was in the first intake of students through the high school. So it was pretty significant in effect, I thought. But when I arrived, I only found that there were two students from my original class. There were about 40 students in the original class, as I recall, but only two of them had come to the reunion. But as we talked, and I talked with other students too in other years, we talked about the teachers and and in particular the science teacher, because that was one of the subjects I was very good at and took a lot of interest in. We had, I thought, a very good science teacher. And I remember learning the order of the planets in the solar system and how they were supposed to have formed from a sort of gas and dust condensing into the planets as they circulate around the sun, that these were this dust cloud somehow spun off the sun. And we learnt the planets all the way out to Pluto being the last planet. Well, of course, as I said, that was back in 1959. I remember learning about that in first year science. We had to learn the order of the planets there. But in July 2015, we know that the spacecraft flew past Pluto, and the planet, well, what was called a planet was downgraded to a Kuiper belt sort of object out there. And so things had changed, but this, and it's no longer regarded as a planet as such, but it is still quite a large object out there, and it has its own moons and so forth. And one of the interesting findings, though, was after this spacecraft, the New Horizons spacecraft, it was called. It took 9.5 years for it to reach Pluto, so it gives us a bit of the idea of the size. But when the spacecraft got there and began taking images of Pluto and so forth in greater detail now than anyone had ever seen before, it provided a totally different picture to what the scientists had thought. And the bottom line was that the overall evidence was that Pluto was very young, much, much younger than the solar system. I thought this is quite significant, because again through the week, just the other week talking with people, it seems that a number of Christians have a problem with believing that on the fourth day of creation, the solar system and the stars were created. And I think there are a number of issues that have led to this. I think we've got the radiometric dating issue of the rocks being very old and so forth, and they've used similar methods of looking at the ratios of different isotopes to estimate the age of the universe, and they get these very old ages of 14 billion years and so forth for the age of the universe. But I need to remember that when they're working out these ages, they're based on just so many unproven assumptions, and also what was before then, and how did it create? We need to, bear in mind there's still no known mechanism that can explain the formation of the universe and the origin of the universe. Sure, scientists talk lots about different things, the Big Bang Theory and dark energy and dark matter and all these sort of things, and they have their mathematical equations. But the evidence that those mathematical equations are real And the evidence for the existence of the so-called dark matter, which is required for the gaseous material, the gravitational force to pull it together to clump in the first place and so forth, and dark energy that somehow caused the universe to expand and all these sort of things, they just haven't been observed. There's no evidence of those things there. And we have all the other problems that point to the fact that the universe was, created in such a way that it was just created instantly. Why? Because we have this uniform distribution of heat throughout the universe, across the universe. There's not enough time really for this radiation to dissipate and travel and become uniform. It was only 14 billion years old, and of course there's so much evidence too that the universe is young, and also. And this is one of the things that is coming back from one of the important evidences, that is coming back from Pluto. When we look within our solar system as well, it is young. Now, I've talked about that, in previous ones, but just recently I was reading up quite an interesting article on this research, on the data that the New Horizons spacecraft sent back, the pictures and so forth. So Pluto has a large moon, Charon, Charon, and it's very interesting that this Pluto being so far out should be, really so cold, but the evidence is there. As I mentioned in one of the earlier programs, that these planets that are way out there, are way far out, are much warmer than they should be. They should have cooled down far sooner. And in particular, for example, Pluto being out there, they'd detected earlier on back in the 1990s that Pluto had an atmosphere. And by studying the spectra that they got coming back, the light spectra, they saw the vibrational spectra for gases such as nitrogen, methane and carbon dioxide, and also some hydrocarbons. So there was a little bit of carbon out there combined with the hydrogen. And one of the interesting things, of course, is in this theory, because now, you've got these objects out there that are just meant to be, fragments so much. The surface of the moon, Charon, was very different from the surface of Pluto. In other words, Charon's surface was composed mostly of ice formed from water. So you can have ice formed from methane and these other gases too, these other molecules too. They form the solid form. But this was water ice. And Pluto was also had this atmosphere of gases. And so they thought that because now Pluto was moving away from the sun at this particular time when the New Horizons spacecraft flew through, that the atmosphere would collapse in some sort of freeze-out. But when the spacecraft arrived, the atmosphere was still there, was still dynamic, it was still warm. So how is it heated? How is it still got this heat? And this is a major problem for scientists trying to understand how this can still be warm, this planet can have the temperature it has. The other thing that they found, of course, out there was that there were very few craters on the surface of Pluto. And this was, again, a large problem for understanding if Pluto was really billions of years old, as it was supposed to be. It should have been bombarded by other objects in the Kuiper belt for billions of years. And some of the scientists comment that one of the most stunning things about the initial images of Pluto's surface, particularly its southeast quadrant, was that there wasn't a single impact crater, not a single impact crater in that whole southeast quadrant that was photographed. And it means that, again, this planet has to be young. And this is, again, more evidence, powerful evidence, that the solar system is young, very young. And the atmosphere is young. Now, one of the ways that they were able to measure here and do some measurements was that they were measuring that nitrogen on the surface of Pluto was escaping into the atmosphere at about 500 tonnes an hour. And that is actually, according to the data here, 500 times faster than the rate of Mars. So again, all of Pluto's nitrogen should have just dissipated thousands of years ago, but it's still there. And so this is, a huge problem for scientists. And scientists have had to come up with that somehow a passing comet redeposited some nitrogen there and all these fanciful things. So the fact that we have this very fast rate of nitrogen depletion, but yet there's still plenty of nitrogen there, is again powerful evidence that this planet is really only thousands of years old. Again, there's no explanation for the internal heat source in these planets, and again, we have this evidence from just so many different angles that point to the planet being quite young. And there's similar problems I think I mentioned previously too. If we go to Neptune and with its moon Triton, with the evidence of recent water volcanism and so forth. So again, when we look at this big picture, we find as we're delving more into astronomy and we're getting better data out there on our solar system, it's pointing to a younger and younger and younger solar system. And it fits the Earth, the Bible account that the whole solar system was only created thousands of years ago. And this is quite important as I hear conversations among Christians that are trying to come up with all sorts of alternate theories about how to interpret Genesis and, whether the solar system was very old and then there was a previous Earth and it was, the Earth was previously inhabited by the dinosaurs and so forth, and then it was destroyed. All the dinosaurs and everything were destroyed, and then God started again. All these stories to try and accommodate these long ages, and also the starlight travel, the time travel problem with light. And I've been thinking about this because this has been another topic that has been coming up and being discussed with regard to the light from the distant stars. And I have mentioned this before. But when we think about it, God created the Earth and the solar system and life on Earth in just 6 days. And part of that 6 days, on the last day, he created man, created Adam and Eve, and with the ability to propagate and populate the earth, and he created them in the image of God. And in chapter 2, when you read in chapter 2 of Genesis there, you find that God created man out of the dust of the ground. He formed man, and then later he formed woman. But reading in Genesis there, it talks about, and I think it's around about in Genesis chapter 2, then one of the first things God says is he talks to man and he tells him about the food he can eat, that the food that he has given him. And it's very interesting, and I've been thinking about this, that We were created to have communion with God, to communicate with God. We were given this mind, this brain to communicate with God. And God walked with man. God was there. Jesus was there with that couple. And we know the story that, after Satan tempted them and they believed Satan and Adam and Eve did the wrong thing and ate the tree and so forth. And God again spoke to them. But God was there. God wanted to fellowship with them. And we can see that this was the whole creation. Now, it struck me that if we have this time-light problem, if there was really a time-light problem, why would God create all the stars but have them that they were there in the past? So that when we look at the stars, what we're viewing is history or things that happened billions of years ago or millions of years ago, because what we have is the starlight problem. Light takes billions or millions of years to travel here if we assume the speed of light as 300,000 kilometres per second. It's going to take a long time for that light to get from those stars here to Earth. And I was thinking, why would God do that? Why wouldn't he create it so that we can see things instantly? And as I was doing some reading in this, I realised that a couple of hundred years ago, when they first started doing measurements to attempt to measure the speed of light, this began to raise these issues of the light from the distant stars. But what they didn't realise, of course, was that they were measuring the average speed of light. In other words, they were measuring the speed of light that it takes to go and come back, a signal to go and come back. And it's very interesting, and I may have mentioned this before too, that when we look at Maxwell's equations, when we look at synchronicity and Einstein's equations for synchronicity, Einstein believed that light, the speed of light was isotropic. It was the same in all directions. And so he chose a particular value for a function, epsilon in the equation, of 0.5, a half. But as I pointed out, I think earlier, if we simply choose the value 1 for that particular constant, and what happens is this: we have instantaneous light travel from a distant object to us. But the light travelling back travels at a slower speed. Now, some people might say, well, look, this is counterintuitive. But God has created the universe for us, and this is the whole message of the Bible, is that we are special. And people say, well, why would you do that? Well, we need to remember that we have other instantaneous interactions in the universe over very long distances. And Einstein didn't think this was possible either, and he set up the Einstein-Podolsky-Rosen thought experiment back in, I think it was about 1939, actually it was first published, in which he claimed that the instantaneous predictions of quantum mechanics couldn't happen, that you couldn't have an instantaneous reaction or instantaneous communication over distance. It had to travel at the speed of light. It was limited to travel at the speed of light. Now, of course, many years later, there were other theoretical physicists that worked on this and developed experimental methods whereby we could look at that. And Alain, his name is Frenchman, Aspect, and his team did the experiments back in the 1980s, I think it was, early 1980s, where they showed, yes, these instantaneous communication interactions occur faster than the speed of light. They occur instantaneously. And so we have this evidence. This is another area, Einstein wasn't right in all his assumptions that he made. We need to also remember that when we look at Maxwell's equations and when we look at the light situation, choosing one for the epsilon value in the synchronicity or the time. It's an equation for synchronising clocks at distances. And it's looking at the properties of time on these clocks. And so there's an equation that you can look this up. So it's Einstein's synchronicity equation, synchronising the clocks. That it doesn't violate any of the laws of physics. It doesn't violate any of the laws of quantum mechanics by choosing epsilon as one. As a matter of fact, it makes sense in terms of the overall picture of the types of constants that operate in the universe. And the other thing is that there's no empirical way of actually us measuring what epsilon is. We can't actually measure it. So we're not violating, by that assumption, any known laws of physics. And this is very important, but it explains something, and that is that what we're looking at out there is actually happening in our time frame, on our time scale here. Some of you also may recognise that speed, changes depending on how you are travelling, and the time is a fascinating study in itself. The whole concept of time, and we know that God is outside time as well. And so the whole concept that we can instantaneously see these things. And so what we're seeing out there, when we see these explosions and nebulae forming and this sort of thing, they're happening on our time scale. And I've often wondered about this as I've looked at the astronomical data. Why is this happening on our time scale now? Why can we see all these things happening now? And they're relevant to us, if really they happened billions and billions of years ago. And I think it really explains, well, they're not happening billions of years ago. They're happening right now. And we can see the world out there instantaneously. And so this is very important to remember and understand this, that when people talk about the speed of light, there's no way that we can actually measure the one-way speed of light, because we can't synchronise the clock. Why? Because we can't send a signal that tells us when the clock starts. And when you do the maths, you look up the equations, when you do the maths, there's no way that we can measure it. We are limited to only measuring the average speed of light, not the one-way speed of light. And having a one-way speed of light as instantaneous fits so many things. It explains so many things in the universe. When we combine this to the evidence that we're seeing now as we're looking at the planets, the solar system as young, and even the surface of the Earth. I know people get worried about, well, hang on, what about the billions of years of dating and this sort of thing? Well, there's some data, there's some studies that were done on erosion rates in New Guinea, on a volcano in New Guinea, and that was nearly 20 metres per 1,000 years is the erosion rate there. Now, if we look at the average thickness of, say, the American continent, is again, the average thickness is calculated about just over 600 metres. At 20 metres per year, per 1,000 years, that's, the continent would erode away in 30,000 years. So in Washington, on Mount Rainier, we've got an erosion rate there of 8 metres per 1,000 years. So again, the fact that they date these continents as billions of years old from their radiometric dating methods, and when we look at these erosion rates, in the Himalayas, by the way, the erosion rates there are about 1 metre per 1,000 years. And so again, these represent, we think, oh, well, it's not, not a metre in 1,000 years doesn't seem much. But if you're claiming that they're thousands of millions years old, billions of years old, it makes a huge difference. They can't be that old. So again, this is telling us our radiometric is clear evidence, and there's many other evidence, so that our radiometric dating methods aren't correct. I was looking at some data just the other day too on dating the lava from Mount St Helens. And again, there are a number of analysis were done of different minerals in the lava, analysing the different mineral crystals in the lava from the eruption in the 1981, I think it was. That again, these are dating hundreds of thousands of years old to I think the one age was 2.8 million years old. And the lava at the time of dating was about 20 years old. So the evidence is there pointing. We see the evidence in the from the planets now. We're getting this really good data from Pluto. We've had these erosion data, and as I said, came across some data there of very high rates of erosion now being measured in New Guinea, in some of the places in the United States, where it would only take tens of thousands of years for the continent to be totally eroded away. We've got a major problem with thinking that the Earth is very old and the solar system is very old. And when we realise too that the time-light travel problem is something that back in 1925, they looked at that and realised that, again, light from distant stars could be instantaneous, but it just hasn't been taught in the schools and in the physics classes. Why? Because people want to believe that the universe is old. But yet, up till they started measuring the speed of light back in the 1800s, most of the scientists up to that time again thought that when they were looking out in space, what they were seeing was actually happening in our real time. And I think it makes so much sense that that's the way God would set it up. We have some really fascinating things out in science, and the evidence is just continuing to show us that the Bible is a true account of God's interaction with man, trying to draw man back to himself. You remember these programs can be listened to again on, if you Google 3ABN Australia, or one word, .org.au, and click on Listen. You've been listening to Faith and Science. I'm Dr. John Ashton. Have a great day.
You've been listening to a production of 3ABN Australia Radio.